Welcome to e-sipnayan. For today's video, we are going to discuss relations and functions under the subject General Mathematics. But before we proceed, do not forget to hit like and subscribe so that you get notified once we upload new videos. For this video, these are the learning objectives that you're going to achieve hopefully at the end. First, you should be able to differentiate the relation from a function, then determine whether a given set of ordered pair is a function or not. Next, determine whether a mapping diagram is a function or not. And lastly, determine whether a graph is a function or not. So to start off, here are some terms to remember. And the first word that I want you to remember is the word relation. So when we say relation, it is defined as the set of ordered pairs. When we say ordered pair, it is in terms of x and y coordinates, such that for every x, there corresponds at least one value of y. So since we're talking about set here, it should be written in this form. So G here represents the set, and then the elements of the set are ordered pairs given by 2, -1, 4, 0, 2, and 1. So this is an example of a relation. It is a set of ordered pairs, and we can see that for every x, there corresponds at least one value of y. So what are these x and y coordinates? For this ordered pair, 2 is x, -1 is y. 4 is x, 0 is y. Then lastly, 2 is x, then 1 is y. So that is what we mean by a relation. Next term that you need to remember is the term function. Function is defined as a relation if for each x, there is one and only one y. So when we say that a function is a relation, it should satisfy as well the definition of a relation. Hence, it should be a set of ordered pairs, again in terms of x and y. Then, this is the special feature of a function, and this is what makes it different from a relation. Given a set of ordered pairs, x coordinate should not repeat, but y coordinate can repeat. Okay, so let's now try to compare functions and relations through a series of illustration. So we know that relation and functions are related in such a way that function is a special type of relation. So they are both a set of ordered pairs. What's the difference between the two? Let's try to compare them using a Venn diagram. Okay, so let this first circle be for relation, then the circle to the right for function. So what is the similarity? First, they are both a set of ordered pairs. And how can we differentiate easily relation from a function? For a relation, it is any set of ordered pair. Whereas for a function, the x-coordinate may not be repeated or should not be repeated given a set of ordered pairs. So basically, that is the major comparison between a relation and a function. Moving on, let's now discuss how to identify functions given a set of ordered pairs. So let's have several examples. Our task is to simply identify whether the given set of ordered pairs is a function or not. So this will be our only hint. The x-coordinate should not repeat. Let's now proceed to example number 1. Given here is set A, and the elements are represented by a set. So basically, to identify whether this set is a function or not, we simply need to take note of the x values and then make sure that no value is being repeated. So let me list all of the values of x in this portion of the screen. Okay, so let's now identify the x values given the set. So the first x coordinate is 1, then 7, -1, then lastly 3. Hence, here are the values of the x-coordinates given a set. And for us to be able to identify whether it's a function or not, we simply need to see or take note whether or not there are repeated values. So the values again are 1, 7, -1, and 3. Obviously, no values of x are being repeated. Therefore, we can already conclude that this given set, for set A, is a function. Okay, moving on to another example, we have another set A. the values of the ordered pairs are -2, 1, 10, 7, 2, -2, and -2, 1. Again, our only goal is to identify all values of x and make sure that no value is being repeated. So let me list again all the values of x here. The first value of x given this set is -2, then 10, 2, and lastly -2. So I would like to organize them in this manner. It's up to you how you're going to organize your values of x. And then next thing that we need to do is again to analyze and take note if values of x here are being repeated. So the values again are -2, 10, 2, and another -2. So if you notice, the x coordinate number 2 appears twice in this given set. Hence, this is not a function. That is how simply we're going to identify whether the given set of ordered pair is a function or not. Let's have more examples, but this time let's fast track. Okay, so number 3, we have here a given again set, and the values of the ordered pairs are 0, 1, 2, 0, 9, 0, 8, and -1. Again, our task is to simply take note of the values of x and make sure nothing is being repeated. So the values of x are 0, 2, 9, and 8. Technically, there are no x values repeated, therefore it is a function. Number 4, again, let's check the values of x. We have -1, 2, -8, and -1. And if you notice, -1 here is being repeated. Hence, we can say that this set is not a function. And last example, again, we take note of the values of x. The values of x are 5, 0, 4, and -2. In this last example, no x values is being repeated, therefore it is a function. Let's now proceed in identifying functions using mapping. But before that, let me discuss what mapping is all about. So a mapping shows how the elements are paired, and a mapping diagram consists of 2 parallel columns. So here below is an example of a mapping diagram. So in the definition, the 2 parallel columns here are represented by the 2 vertical ellipses, or these 2 ovals we're seeing here below. So the first column is designated for the values of x, and the other column, or the column to the right, is designated for the values of y. So basically, the mapping is an illustration showing the summary of values of x and y and their corresponding relationship. For you to be able to understand that better, let's have examples. So for example, number 1, our task is to simply identify whether the given mapping is a function or not. So again, our hint here is that the x coordinate should not repeat. Here is an example of a mapping. So we have here set G, and then this is the first column representing the values of x. So the values of x are 1, 7, -1, and 3. And the second column is designated for the values of y, which are 3, 5, 0, and 5. So how does this mapping works? So for this mapping, we can simply see what is the value of x and what is the value of y given or when we relate it to the lines. Okay, so for the first one, the first value of x here is 1, and it is mapped to the y value 3. Therefore, if you write this one in ordered pair, x value is 1, y value is 3. As simple as that one. Next, for value or for the x value 7, it is directly mapped to y value 5. Hence, if you write it in terms of coordinates, it will be 7, 5. Next, for x value -1, we see that it is mapped to y value 5. Therefore, if we write it as an ordered pair, it can be written as -1 and 5. And lastly, x value is 3. It is directly mapped to, this time, 0. Therefore, it can be written as 3, 0. So we can write this mapping as a set of ordered pairs, and the set is G. This is the name, or this is the set rather, and then the elements will contain the ordered pairs. Okay, so since no x value here is being repeated, so the x values are 1, 7, -1, and 3. There are no x values repeated. Therefore, we can say that this mapping is a function, or this mapping represents a function. So that is how mapping works. Let's have another example for you to further understand mapping. So this is another example of a mapping, and it is represented as a set K. Okay, so let's now identify the ordered pairs given the mapping diagram. So the first value of x is 5. It is mapped to the y value of -1. Therefore, as an ordered pair, it can be written as 5, -1. Next, for x value 4, it is again mapped to -1 as the y value. Hence, we can write it as not -4, but rather +4, -1. Next, for x value 8, it is mapped with y value 0. Therefore, the ordered pair is 8, 0. And lastly, for the x value 9, it is directly mapped to the y value 4. Therefore, it can be written as an ordered pair 9, 4. Okay, so we can write this mapping diagram again in terms of set. And again, for us to check if it is a function or not, let's check the x values. So we have 5, 4, 8, and 9. So since no x value is being repeated, then we can say that this mapping diagram represents a function. Okay, moving on, this is example number 3, and this is the map. Again, we do the same procedure. So for this map, it is represented by set S. Okay, so let's now identify the mapping relationship. So we have here the x value 1. It is mapped to 2 y values. If you notice, there's only one value of x, but there are 2 maps. So the first ordered pair can be represented when x is 1, it is mapped to y value 6. So that can also be written as 1, 6. Okay, another possible ordered pair to be formed given this mapping is that the x value is x, and then it is mapped to y value 4. So that is represented by an ordered pair 1, 4. Moving on, we have the second x value 5. It is mapped again to the y value 4. So that is represented as an ordered pair 5, 4. And lastly, x value is 7. It is mapped again with the y value 4. Again, we can write this as a set given by set S equals 1, 6, 1, 4, 5, 4, and 7, 4. So again, for us to be able to know whether the map or the mapping represents a function or not, we simply check the values of x. So the values of x here are 1, 1, 5, and 7. And notice that the x value 1 is repeated twice. Therefore, this mapping does not represent a function. So moving on, let's now discuss how to identify whether graphs are functions or not. And there's a test to do that. And that is the so-called vertical line test. So what is a vertical line test? It is used to determine whether a graph represents a function or not. So the only skill needed here is for you to know how to draw a vertical line. And I know that you know that. So how does it work? When you draw a vertical line on the graph, it should only intersect at one point. Again, let me emphasize, the point of intersection should only be 1. So given a graph, we simply need to draw a vertical line and check how many points of intersections are there, and it should only be 1. Okay, let's have an example for you to be able to understand how to apply the vertical line test. So for this example, you apply the vertical line test and check whether the given graph is a function or not. Again, the hint is that there should only be 1 point of intersection. So for this example, given is the graph of y equals 5, illustrated in this graph. So how do we do the vertical line test? You simply need to draw a vertical line anywhere in the graph. So if you want to draw a line here, it's okay. But if you also want to draw the line over here, it's also okay. But maybe I want to draw my line here, it's okay. So it's up to you which part of the graph or which portion of the graph you are going to draw the vertical line. Okay, then after drawing the vertical line, check for the points of intersection. So the graph of y equals 5 is the horizontal red line here, and my vertical test line is this vertical blue line. And if you notice, there's only one point of intersection. Hence, we can say that y equals 5, or this given graph represents a function because there is only one point of intersection. So that is how easy you apply the vertical line test. Let's have another example. What if we have the equation x equals 2? It is represented by this graph. And notice class that when we draw a vertical line in the given graph of x equals 2, it is overlapping. What do we mean when they overlap? It means infinitely many points of intersection, or there are infinitely many points of intersection because they are overlapping. Therefore, we can say that this is not a function because there are infinitely many points of intersection. Okay, next example, we have the equation y equals 2x plus 1 represented by this graph. So again, it's up to you where you would like to draw the vertical line. But say for example, I want to draw my vertical line here. Then check for points of intersection. Again, there's only one point of intersection given this diagonal line and my vertical line. Okay, hence we consider this graph as a function. Next example, we have here x squared equals y represented by this curve red line here. So again, to identify whether the graph is a function or not, we apply the vertical line test. So let's say for example, I want to draw my vertical line somewhere here in the graph, and then again check for points of intersection, and if you notice, there's only one point of intersection. Therefore, we can say that this equation is a function. Okay, another example, we have x equals y squared represented again by this red curve over here. So again, simply draw a vertical line anywhere in the graph, and this time, if you notice and look closely, there will be 2 points of intersection. The first point of intersection is here, and then the other one is here. So since there are 2 points of intersection, it does not satisfy the vertical line test. Therefore, it is not a function, or this graph does not represent a function. Okay, another example is x squared plus y squared equals 1 represented by this circle. And again, to apply the vertical line test, simply draw a vertical line anywhere in the graph. So say for example, I want to draw the vertical line here. And again, looking closely, there will be 2 points of intersection. This is the first point, and this is the second point of intersection. So since there are 2 points of intersection, therefore we can say that this circle, or this graph of a circle, does not represent a function. Okay, and last example, we have here y equals the absolute value of x represented by this V-shaped graph. So again, simply draw a vertical line anywhere in the graph, and then if we check the point of intersection, there's only one somewhere here. Okay, so since there's only one point of intersection, therefore it is a function. Okay, so to sum things up for this video, please remember the following. A set of ordered pairs is a function if no x-coordinate is repeated. Next, in mapping diagram, no x value should be mapped more than once to a y value for it to be considered as a function. Then, use the vertical line test to determine whether a graph is a function or not. And lastly, to perform the vertical line test, simply draw a vertical line on a given graph, and then the point of intersection should only be 1. So that's all for this video. Thank you for watching.